think the other hour had like 35 minutes to, that doesn't seem right. Maybe 30. Okay, you don't have this. So here's your notes, right? And then I just did a screenshot there of section 2.8. When I say inverse, you say switch X and Y, and that's the first time we did that. And that is actually part of this. If you look at your homework, I think that's the first one that's stamped. If you have your stamps here, but this is the notes, not the homework. I should have pulled homework question ones up, but anyway, it's the same. When I say inverse, you say switch X and Y. Remember this? You don't have to write this down. Just get your mind right here. Then do algebra, add 7, then divide by 3. Remember domain and range. What's the word? Starts with an E. Exchange. Yeah, you said it. Good. That just means these flip. It gets important when you have this one. No, not this one, because cubics are okay. Cubics are 1-to-1. Remember some of that terminology? You'll get a review packet tomorrow. I'm going to do a quizzes tomorrow, and then maybe just leave you alone Wednesday or what have you. But you'll see these questions again. There's quite a few inverse questions on the review packet. So I just wanted to spend a moment to remind you. Switch X and Y. Opposite of cubing is cube rooting. Cube rooting does not have issues like square roots. You can cube root a negative. Okay, now I mentioned that. Remember, we had to remember. That's great stuff. That this has a domain restriction. You can't square root a negative. And the reason we care about that is the red is the original. That's this graph. That's only half of a parabola. So when I find the inverse of this and I get an x squared, which is a parabola, we have to have a limited domain, right? Because of where it came from. So that I only get this half of the parabola here. So we don't have to worry about this with what we're doing today. I just thought it'd be a good time to remind you that this was part of this section. Something happened, as usuals. All right. And then the last one, there's a parabola given, but with a restriction, so that you only get half of the parabola. And then when you find the inverse, you do get that square root graph, which is half of a parabola going right. All right, so little restrictions on domain and range. Then the last monster one, which you'll see, you got a monster one on your review tomorrow. Finding the inverse of a double xer, a rational function, right? And that you'll see in your 2.8 notes as well, and homework. That's why I get it back to you, so you get to look at it and at any point throughout. I don't care what all of this says. When I say inverse, you say switch X and Y, and that's all we're going to do. We're going to get into it. Not that it's bad up there. It's there for you to read if you want. But it does talk about, how a logarithm is the inverse of an exponential. Okay, let's do it. When I say inverse, you say switch X and Y, and we're in action here. So we didn't formally do this. So we did have an inverse chapter, but we didn't even know what a logarithm was yet when we did that inverse thing. So now we do, and now we can find the inverse of an exponential through math. And then how do I get rid of negative 15? I add it to both sides. How do I get rid of 3 times? Because I cannot multiply these two. I divide. We at this point should be able to handle this quicker math. And then I am going to show you something here. Yeehaw. Sorry, you don't get that option with your pen. I'm going to show you something here. Whatever I do to one side, say it, do to the other. Okay, so I'm in a quandary here. Like, do we know how to change a logarithm to an exponent? Some of the other teachers have hearts. Anyone ever hear the heart method or see a friend do the heart method of a logarithm? Anyone? Yes? Okay. Maybe, was it in tutoring or no, or just you saw it? I think I might have referenced it there as well. So base, go this way, exponent equals answer. Does that look like a heart a little bit? Right? But you got to go this way. Or that's changing a logarithm to an exponent. Whatever you do to one side, do to the other. You could log base 2 both sides. And then this is what I mean about, I don't know which one I want to show you, so I'll show you both. This is what you see in AP work when I show a key, but it's from, an AP source. they will do this. They will show the log base 2 of both sides. Because log base 2 of 2 raised to this power is just this power. It's the same idea, though. You get the same results. I'll change colors for changing a logarithm to an exponent. You know what? I kind of like these in parentheses, so you understand this is locked in the logarithm. That's the answer or argument of the logarithm. It's stuck there. But here we go, different color. We'll go blue here. Base, exponent, answer, exponent all by its lonesome. This is what's supposed to happen changing an exponent to a log. One or the other, I don't care. I don't need to see this. If you know how to change a logarithm to an exponent, you want to start doing the heart, go for it. Okay? When we come back from break, we're going to be solving logarithm equations. I'm going to show you that again, whatever I do to one side, do to the other, or change the log to an exponent or exponent to a log. It's the same thing. Then the last thing we do is subtract 4. Maybe I'll change colors one more time. We'll go to black here. And then call this the inverse of f of x. So it's this chunk, log base 2 of x plus 15 all over 3, and then subtract 4. And that 4 is not part of that logarithm, so it's outside of it. Okay? You have to worry about what does the over 3 mean on the inside and all that other stuff. You're just finding the inverse. So you're just doing that math. Draw a little line in the sand here and do the same thing and go faster with these. When I say inverse, you say switch x and y. They are saying it too. We're just a little low on a Monday, right? Monday. Da, 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 da. You know that song? No. Subtract 7, divide by 4. We got to be able to do that simple math. And then this is e raised to the y minus 1. If you want, then what you would do to both sides, if you like that, is ln both sides. Or I'll choose a different color, purple. Base, exponents, answer. Base is log base e of answer, x minus 7 all over 4. I think parentheses are a good idea. Equals exponent, the whole idea of a logarithm. Okay, by the way, ln of e raised to the y minus 1 is just y minus 1. So it still results in the same thing I'm talking about here. Okay, ln is log base e, so you are log base e-ing that x minus 7. So you do whatever you want, just do it right. Whatever way you pick, know how to do it and get it memorized. All right, and then this is the inverse of, what's this one named? It is f of x again. So the inverse of f of x equals log base e, which is ln, of this chunk of stuff, all in the a position argument, and then add 1 to both sides. So I got to add 1 and then flip-flop the equation. Okay, that's it. That's all you got to do. Now you want to talk about domain and range with these. You have enough domain and range questions when you actually see a graph. So of these are a little bit wonky though with the complicated argument positions. Now I have a logarithm, and then I'll have to change it to an exponent. Okay, all right. But when I say inverse, you say switch x and y again. And then I hope you can handle my simple algebraic skills. All right. Is kind of the thing that's killing some people here. Just basic algebra skills, the ability to subtract 6 and then divide by -3 and see that. That's how you undo those operations in order to get that logarithm all by its lonesome. Here comes the heart again. I hope I'm doing it right. I'm not a heart guy. But base exponents equals answer. Okay? Answer position. What's wrong? Huh? It's a 4. Is that what you're saying? Oh, this x is a y. Whoops. Yeah, and then whoops. Whoa, that's on the internet. Oh boy, a mistake. Thank you. Yeah, fire. Look at that guy back there. New improved, right? Mm-hmm. All right, but anyway, look at this. Hearts in the way. No hearts. Okay, or you want to get nuts? Let's get nuts. You could 5 raised to both sides. What is he doing? This is whatever I do to one side, say it. Okay, now what's 5 raised to the log base 5 of y minus 4? Just y minus 4. This is a property. This is a property, right? And then this literally turns into 5 raised to this complicated exponent. And then don't be canceled a -6 and a -3. That's bad algebra. That's all I have to say about that. Then the last step is add 4. So what is this one called? G of x. So now we'll call it the inverse of g of x equals 5 raised to the x minus 6 all over -3 complicated power plus a big fat 4 not part of the exponent. So that would be at least up 4. You would get that. Then you got a complicated exponent to see other transformations. We just don't want to get into that right now. Not in this one. I just want to find inverses. Just want to get through the mathematical situation. Everyone okay? When I say inverse, you say switch x and y one. It's just redundancies. Let me make sure I don't make a mistake this time. That is a y, all right? Making sure. And then all you got to do is get rid of that plus 10 this time. So it's x minus 10. And then we have our 3 positions. X minus 10 equals ln. If you want to make it log base e, go for it. So that you know what the base is. Whatever I do to one side, say it's. That's raising e to the each side. It's such a weird, whatever I do to one side, I do to the other. So strange. But the reason is, and again, you're severely and totally what? Behind if you don't get e raised to the log base e. This whole reason you did it is a free 2y plus 3. That's a property. You've been asked on that many quizzes over and over and over again. We only have, what, 5, 6, 7 more days together? Of those 7 days, 3 of them are going to be quizzes. Yelling, yeah. Why'd you get that wrong? All right, judgment. E to the x minus 10. So we do have one tomorrow. And then I'll leave you alone Wednesday. Thursday's the quiz. Friday, I'll leave you alone. I think it's Monday, Tuesday. It's our last 2 days before the final. You guys are first, right? So 1, 2, 4. I put it in the calendar. Look, hopefully this is legal that I put up there. See, it is there. Isn't that nice? So 1, 2, 4. It's stuck what they have posted on the internet in our calendar. So we're getting to it. All right. Sorry, this is in the way. And then, okay, here's what the final answer is. What is this called? Inverse of h of x. I only got one more after this. Add 3. Wrong. Subtract 3. So this is e to the x minus 10 minus 3. Watch out for my fat face there. And then divide by 2. Just go ahead and do this. Divide the whole side by 2, and you should be fine. If you wanted to multiply by a half, then it'd be a half in front of the e, and then 3 halves would be the other term if you divided those separately. Okay, then I want you to do me a favor and read this for a second and see if you can figure out something. So number 5. By the way, input, say it. Output. It's talking about an ACT. I'm teaching this outside of our school ACT course in January. Well, I tell you, going over practice problems, input, output really helped a lot on some of the questions. We had some complicated ones we all went through, and by golly, came down to input, output. Oh, I have another thing. Output. What do you think you'd say next? Output. Input. Why? When I say inverse, you say switch x and y. So see if you can figure out something about this. Because I saw some other teachers do something different that were much more complicated. Like they found the inverse of this equation. You don't even need to. All right, let's see if anyone picked up on it. What is this? What is this? Is this an input or an output, meaning is that x or y for k of x, which k of x is the inverse of this. So what does that 1 mean for k of x? Is it the x or the y? How many people say x? Raise your hand. No one's saying anything. No one's raising their hand. Oh, no, I think he went like this one. No one else raised, so he's just like, so is it a Y? Raise your hand if you think it's a Y. Nobody raised their hand at this point. This is hilarious. Is it a Z? I don't know. Are we making up letters now? All right, so which one is it? X, you have to raise your hand if you think it's X. Come on. 3, 2, 1. We got some people now. And then the one's now scratching his ear. I'm not sure if the hand's going up yet or is it up or not? Oh, now he's sniffing his hand. Something's going on over there. I don't really know what's happening. Okay, how many people say it's a Y? It's got to be the rest of you. Raise your hand. Raise your hand if you did raise your hand. Did you raise your hand once? Give me that hand. All right. This is getting weird. All right. The answer is this is Y. For the love of dog, read this. For what value of, say that. What letter is that? X. Does k of x equal 1, which makes 1 what? Y. So this is x comma 1 for the inverse of h. So what does that mean? This is for h. When I say inverse, you say switch x and y. What does 1 represent for h then? The x or the y coordinate? The x. Okay? Because these flip, right? So really all I have to do is input, say it. I just got to input 1 into this to get the y coordinate. So h of 1. And then 3 to the, this is what I try to get you guys to do when you're graphing, and it's been a disaster. 3 squared is 9. 9 minus 2 is 7. So now I ask you, what is the x coordinate of the inverse of h? What's the answer? 7. I didn't have to do anything. It is an input-output. But output, input, and then you got to flip it around and understand the context of the question, what's happening. Okay, everyone should know this. So 1, 7 turns into 7, 1. That's how come this all worked out. So the answer is 7 for the question at the end of this sentence. I don't know. So that's instantly what I thought of in problem solving for this. I don't really have to fully find the inverse. I got something different I can do. What the other teachers did is they found the inverse of this, and then they set it equal to 1, and then they solved. That was like 2 big algebra steps. I just kind of figured out what's going on. All right.